everyone, I'm Dr. Goh Wan Inn and I will present this chapter, which is Introductions to Prestressed Concrete, and these slides is prepared by IR Dr. Muhammad Sofi Muhammad Noor. Concrete is known for great compression strength but weak in tensions. So the tensile strength of concrete is generally 10% of its compressive strength and normally being ignored. Okay, so let's say you have a concrete with 25 megapascal, so the tensile strength is about only 2.5 megapascal compared to the compressive strength. Okay, so reinforced concrete incorporating steel reinforcing bars to take up the tensile stress in concrete. However, it does not solve problems associated with low tensile strength in concrete. So for example, a simply supported beam under vertical loading, so you can see that this is the example, this is the vertical loadings, okay, cause cracking in tensions due to bending and incline cracks due to shear stress. So this is the shear stress. You can see this orange color. So this is a stress drawn from here to here at the support, okay, and at the midspan. Okay, so you can see that this is the fracture cracks at here, and this is the shear cracks, and this is the fracture cracks, okay, and this is the fracture and shear combinations cracks. So how to prevent this crack? By using the prestressed concrete, we can reduce it. So deteriorations in concrete is mostly manifest through appearance of cracks. So the following is disadvantages of cracks. Okay, so first, cracked concrete prone to corrosions of steel reinforcement. So once concrete cracks, so the reinforcement inside will expose to outside, so it will cause the corrosions after times. So cracked concrete leads to failure under serviceability limit state. So once it cracks, so the strength reduced, so it might fail. And the cracking reduces ability to resist shear. So once it cracks, so of course the strength reduce, so also the shear resistance also reduce. So a cracked structure is less stiffer than the uncracked structures and will deflect more under loads. Okay, so once cracked, everything will be weak, so also it will deflect more. So in order to prevent larger deflections, it requires larger sections. Okay, so hence increase the dead load. So if you want to avoid that, so a good thing is you use the prestressed concrete. So problem in concrete can be solved if subjected to external forces to neutralize tensile stress caused by applied loads. So pre-compressions subjected to concrete is known as prestressed concrete. So we use the pre-compressions, okay, also known as the prestressed concrete, to solve these cracking problems. So a pre-stressed concrete can be defined as introducing external compressive stress into area where tensile stress develop under working load. So you can see this tensile stress, okay, so you can see from this picture, so when the load applied at the plain concrete, it will cracks. So we introduce reinforcement at the bottom to take the load, okay, so it will appear the cracks, okay, for the tensile zone. So what we do is we introduce a prestressed concrete with external compressive stress, okay, at the tensile stress areas. So from this, it will reduce the cracks. Okay, so let's discuss about the methods of prestressing. So prestress is imparted to the concrete members by highly tensioned steel tendons, either using wire, string, or bars. So reacting to the concrete. So the high strength prestressing steel tendon is most often tensioned by using the hydraulic jack. So there are two basic methods of tensioning operations. So there are two methods. So either pre-tensioning or either post-tensioning. Okay, so prestressing, you can divide the two methods, which is pre-tensioning and also post-tensioning. So let's talk about the pretensioning methods. Okay, so this is the pretensioning methods. So prestressing tendons initially tensions between fixed abutment and anchor. So look at this first photos. So applying tensions to tendons. So these steel tendons being pulled by using the hydraulic jack. Okay, and then after that, concrete is being placed carefully, compacted and cured to assure the adequate bonds. So which is mean the casting of concrete. So you pour the concrete and let it have the adequate bonds. Okay, so once the concrete being hardened, the tension in prestressing tendon is released after the concrete achieves its required strength. So after that, okay, so it will be cut. Okay, so the tendon cell will be cut. So the stress is being transferred to the concrete. So this is the pretensioning methods. Okay, so you can see this is the actual photos, okay, for how the pre-stressed concrete by using pretensioning methods. So you can see that this is the first step, okay, before casting, applying the tensions, and then it will pour the concrete inside, okay, number 2, and then after that it will cut the tendons. So this is it. So basically there are 3 steps. The first one, okay, apply the tendon by using the hydraulic jack, concrete casting, and then cut the tendon. So this is the pre-tensioning. Okay, so let's look at the post-tensioning methods. Okay, so just now we have discussed the pre-tensioning, so we go to the post-tensioning now. So first step is concrete is cast first in formwork with provisions of ducts. So the ducts or tubes is placed in the concrete. Okay, so concrete is allowed to harden. So we have a duct here, okay, to place the steel tendons later. So once the concrete hardens, the steel tendons are inserted into the concrete through the ducts. Okay, so this is number 2. So once it's hardened, so the steel tendon will be inserted into the concrete. You can see insert into the concrete, okay, through the ducts by using the hydraulic jacks. So the concrete strength has achieved. Once the concrete strength achieved, the steel is stressed against the end at the end of the units and anchored off. So the hydraulic jack will apply and then pull the steels and then apply the stress. So once the stress at the end, okay, achieve the desired stress, so it will be anchored off. So this putting the concrete in compressions. So this is the 3 step, which is the first one, casting of concrete. Second is tensioning of tendons, and C, number 3, is anchoring the tendons at the stretching ends. So this is some of the actual photos of post-tensioning method. So you can see that this is the steel, okay, the concrete work. Before that, then you have a duct here. Okay, so this is a duct, and then being inserted into the concrete. So it will be cast. Okay, so once it casts, okay, so it will be pulled with the hydraulic jacks, and then the steel will be inserted. So after done complete, it will be cut off. Okay, so being cut off. So this is the pre-stressed concrete by using post-tensioning methods. So this will be delivered to the sites and then being constructed. So this is the long spans bridges, okay, by using the post-tensioning methods. So let's look at the advantages. Okay, so high degree reductions in cracking compared to the normal concrete. And then in comparison to reinforced concrete, the entire concrete cross-sections of pre-stressed concrete resist applied loads. So this is because concrete in tension zones does not experience crackings. Hence, it will take part in carrying the load. And the spans of pre-stressed concrete are longer compared to the reinforced concrete beams. Okay, so you can design the longer span if you're using the pre-stressed beam. And pre-stressing enhance shear strength and fatigue resistance of concrete compared to the normal concrete. And pre-stressed concrete remain uncracked even at the service load conditions. So even at the service load condition, okay, it will still uncrack. So pre-stressing results in maximum economy in size, weight of structural members, thereby economizing the transportations and storage. So pre-stressing is using a lot in the pre-stressed concretes. So once you're using the pre-stressing method, it will reduce in size and weight of the structural members. So it will achieve the economy also. Okay. So what is the disadvantages? So of course it will have the higher material cost. So prestressed concrete requires high quality dense of high strengths. Okay, and then higher tensile strength of steels and adequate ductility. So require complicating tensions equipment and anchoring device. So you need to have the device, else you cannot do it. Okay, constructions require perfect supervision and skills labels. So you need to have the good supervisor, you need to have the good engineers, and you need to have the skills labels to do the work. So what is the materials? So concrete. So the concrete used must be high strength. Okay, it's a major constitutions of all prestressed concrete. So the two major aspects of importance are first the compression and the tensions. Okay, second is the deformations properties, so such as the elasticity modulus, elastic modulus, variations of creep, shrinkage, deformations with times. So the deformational properties are particularly important as they are an important effects on how much prestress is retained in the long terms. Okay, the properties of concrete are given in the table 3.1 in the Eurocode 2, so you can refer to that tables. And then the pre-stressing steels. So the steels used is usually cold-drawn, high-tensile steel wires or alloy steel bar as shown in the photos, and its stress released by the heating strength out about 350 Celsius and allowed to cool slowly to increase the ductility. It has characteristic ultimate strength about 1800 megapascal compared with the 500 megapascal for the high yield reinforcing bar. So pre-stressing steel, you need to use the spacious high tensile steel wires, okay, high tensile steel wires or alloy instead of the high yield reinforcing bars. Okay, the common forms of pre-stressing steels is in practice is a 7-wire strand made of 6 wire spans round a strand centered wire. So this you can see that. Okay, this is the center wire. Okay, the center wire made from 6 wire and sprout around a straight center wire. Okay, so overall, nominal diameter varies from 12.5 millimeter to 18 millimeters. In order to reduce the overall diameter, the normal strength can be passed through a die or compress the cable and reduce the voids. So the prestressing system. So you need to have the system to do it. So prestressing system is a method adopted by manufacturers to stress and anchor the tendons. So there are several system operations with their individual trade names. So the basic equipments required of prestressing are anchorage and hydraulic jacks. So this is the hydraulic jack, you can see. Okay. So this is the anchorage. So you're using this to encourage the steel strands. And this is the applications. So you can see this can use for the bridge, the buildings, okay, the tunnels, the precast concrete structures. And thank you for watching these videos. See you.